Wastewater treatment. Full many the gem of purest race, born in unfathomed cave bed of ocean, and full many the flower of sweetest fragrance, born in a desert is a waste. That is, if substance is present in an art place, then we designate that one as a waste. Wastewater from the human habitation is harmful to the environment, and several points are to be considered. One, spread of disease caused by the bacteria, viruses and parasitic organisms. Removal of oxygen from water of rivers. Due to rapid industrialization process, enormous amount of wastewater is generated from the industries, and these wastewater contains objectionable materials that will lead to harmful effect when they are discharged into an environment. This may cause diseases caused by the bacteria, viruses and parasitic organisms. Removal of oxygen from the water of rivers or lakes which receive the wastewater. Poisoning of rivers or lakes by chemicals and metals originating from the industry, and enrichment of natural waters by the salts such as nitrates and phosphates, which then cause abnormal growth of algae and other plants with undesirable results. Wastewater treatment is the means by which water that has been used and or contaminated by humans or nature is restored to a desirable quality. Water may be treated to any level of quality desired. However, as its purity increases, the cost also increases. The objectives of the wastewater treatment: to separate the solid from the liquid fraction and to concentrate the solids collected from the carrier water. The second one is to remove or render innocuous material that will cause adverse effect when the effluent is subjected to ultimate disposal. Now, classification of wastewater treatment. Wastewater treatment process is categorized as pre-treatment, primary treatment, secondary treatment and tertiary treatment. Sometimes pre-treatment is more than enough for a particular type of wastewater that can be discharged without any harmful or deleterious effect to the environment. Pre-treatment is used to screen large solids, reduce the size of the solids, to remove flotation oil and to equalize fluctuations in the concentration and or flow. Primary treatment includes pre-treatment and refers to the removal of suspended solids either by sedimentation or flotation. Chemicals may be added to remove the suspended particles or sometimes dissolved particles. Secondary treatment. Secondary treatment is a biological process by which we can remove or reduce BOD to a certain level. These biochemical processes are mostly aerobic process and sometimes anaerobic process. A well designed secondary treatment plant can expected to remove 85 to 95% of both BOD and settlable solids. Tertiary treatment may be defined as the treatment in addition to primary and secondary treatment. It aims at further purification of wastewater, final polishing, reduction dissolved solids and disinfection of effluents. Purification of wastewater, final polishing, reduction of dissolved solids and disinfection of effluents. These processes may be integrated into secondary treatment plant or added onto secondary effluent. Tertiary or advanced wastewater treatment can virtually attain any removal efficiency desired. It is mandatory that the composition and the characteristics of wastewater be known and understood in order to design and operate the wastewater treatment plant. Primary treatments. Process under primary treatments are screening, sedimentation, equalization, neutralization and coagulation. Screening. It is the process by which the larger suspended and floating materials such as fibers, papers, wood pieces and fruit skins are removed. The conventional screen system is comprised of two units. First one is known as a coarse screen with 25 to 50 mm size. The second unit is fine screen. In this size, the opening is 0.8 mm to 6 mm depend upon the type of effluent. The accumulated material at the screen must be removed at frequent intervals. Modern mechanical screens are of two types: rotary self-cleaning gravity type units and subtler overhead fed vibratory units. Both are costlier but more effective in reducing the suspended solids. Degree of purification is very high. Sedimentation. It is the settlement of solids by gravity. It does not require mechanical accessories and employed for waste containing high content of settleable solids, or when the waste is given a combined treatment with sewage. Equalization. Different types of wastewater are generated in different parts of industry or different industries as a whole. Different industrial wastewater contains different toxic substances and it poses a serious threat in the treatment process, overall treatment process. Neutralization. Waste with extreme pH should not be discarded without treatment. Hence, neutralization is necessary. Depending on the type and volume of waste, neutralizing material and equipments are chosen. Neutralization of acid waste is done by the following methods. 1. Mixing of waste. Mixing of acid waste with alkaline waste in appropriate proportion can be followed to adjust the pH. It is the cheapest method. 2. Limestone treatment. 3. Lime slurry treatment. 4. Caustic soda treatment. Caustic soda treatment is the most effective method of neutralizing the acid waste. Product formed are also highly soluble in water. Neutralization of alkali waste is done by the following methods. 1. Sulfuric acid treatment. 2. Carbon dioxide treatment. 3. Utilizing the waste boiler flue gas. It is an economical process. CO2 is present approximately 14% in the stack gases, react with the alkalinity of the wastewater to form carbonates. Coagulation. It is the process by which colloidal particles are destabilized by the addition of certain chemicals and consequently aggregated and bound to form a floc which settles rapidly. Normally used coagulants are alum, ferric sulfate, ferrous sulfate, ferric chloride. Alum is the most popular coagulant used both in water and wastewater treatment. Alum ionize in water producing Al(C) plus ions, some of which neutralize the negative charges of the colloids. Most of the aluminum ions, however, react with alkalinity in the water to form insoluble aluminum hydroxide. Secondary treatment. Secondary treatment is the biological process by which the objectionable organic material are oxidized to carbon dioxide and water in the presence of microorganism, oxygen and nutrients. Bacteria are the major microorganism carrying the oxidation. The most common biological treatments includes aerated lagoons, trickling filters, activated sludge process, oxidation ditches, oxidation ponds and anaerobic digestion. The effectiveness of the treatment depends on the bacterial slime, pH, temperature, nutrients, toxic compounds, etc. Aerated lagoons. It is one of the oldest method of wastewater treatment and it is still in use in certain areas. There are certain advantages of aerated lagoons. 90% of the BOD removal is achieved and operation and maintenance are much simpler. The major disadvantage is the requirement of more space. These are the large holding tanks, basins lined with cement. Depth varies from 3 to 5 centimeter. Trickling filtration. It is an effective aerobic biological oxidation method used widely in industries. In this method, highly permeable filter beds, which is made up of rocks of 25 to 100 mm size, are employed. Depth of the bed varies from 1 to 2.5 meter. PVC media and plastics are widely used as a filler or packing material, over which the microorganism forms a floc. Microorganisms working to stabilize the organic waste material are attached to a fixed bed rather than being a floating and suspended nature. Wastewater after primary treatment is sprinkled uniformly over this filter bed through the rotary nozzles. The slimes formed on the stones oxidize the wastewater. Treated wastewater is collected from bed through a under drainage system. Periodically, the film will become so thick that it can no longer be supported on the media and hence it has to be removed from the filter. The sludge will then go to the secondary settling tank and are removed. The removal of organics depends on the following factors: 1. Organic concentration of waste, 2. Temperature, 3, the size of the filter media and the microbial surface area, and depth of the filter, retention time and oxygen transfer rate. Based on the organic loading and slugging intervals, trickling filters are classified into two types: 1, low rate trickling filters; 2, the high rate trickling filters. Advantages: it produces better effluent quality and consistent quality, recover quickly from the shock loads, constant manual attention is not necessary, high cost of construction is the only limiting factor. Activated sludge process: this is a method most versatile biological oxidation process used in industry and also used in the treatment of sewage. In the activated sludge process, there is an aeration basin where the wastewater is allowed to pass through this aeration basin and air is passed. When air is passed, the microorganism is developed in the aeration basin and it degrades the organic material that are present in the wastewater. As the degradation process takes place, the microorganism also grows and it degrades the organic matter to a greater extent. Then it is taken to a settling tank where the microorganism is settled and recycled back. Hence, this process is called an activated sludge process. For the growth of microorganism, we need nutrients. Nitrogen and phosphorus are most important, and when they are in proper quantity, the growth of microorganisms are at a faster rate and degrade the waste to a greater extent. The modifications over conventional activated sludge process are tethered aeration, dispersed aeration, extended aeration, contact stabilization and high rate aerobic treatment systems. Conventional system, oxygen is supplied at a uniform rate throughout the aeration tank, but in fact oxygen demand decreases along the length of the tank as the waste stabilization process occurs. So, oxygen supply can be reduced progressively, which is termed as tapered aeration. In the case of dispersed aeration, instead of reducing the oxygen supply, influent may be passed at several places of aeration tank. It is referred as stepped aeration. If the aeration period is between 8 to 12 hours, it is dispersed aeration. If the aeration period is extended to 18 to 48 hours, this process is known as extended aeration process. By this process, less sludge production due to autolysis of sludge takes place. The advantages of activated sludge process. There are several advantages in the activated sludge process. The sludge produced in the activated sludge process is very less. High quality effluent is obtained in a very small area. With the advantages, there are also disadvantages. 1. Sensitive to shock loads, to toxic and high concentration organic substances. 2. The volume and concentration of the return sludge should be monitored regularly. Last and the most important one is the high cost of operation and maintenance. Oxidation ponds. Oxidation ponds are otherwise known as waste stabilization ponds. Here, there is a large shallow pond in which waste are added to one end of the and the effluent is removed at the other end. Stabilization is brought about mostly by the bacteria and certain extent by protozoa. Oxygen requirement for its metabolism is supplied by algae in the ponds. In turn, algae utilizes carbon dioxide released by the bacteria for its photosynthesis. This mutual symbiotic action is the characteristics of the oxidation pond. Hence, the effective treatment wastes maximum light penetration for photosynthesis of algae, wind action for mixing and maximum natural aeration are necessary. The oxidation ponds are normally 0.5 to 1.5 meter depth. At the topmost part of the oxidation pond, aerobic process takes place, and during the aerobic process, the complex organic material is converted into carbon dioxide and water. And at the bottommost part of the aerobic tank, the anaerobic situation is created, and hence the anaerobic bacteria degrades this complex material that are settled at the bottommost part of the aerobic tank, and the organic materials are converted into methane, carbon dioxide and ammonia. There are several advantages in the oxidation ponds. One, the maintenance of the organic ponds is very less. It does not require any highly skilled personalities for its maintenance. The second one, it requires very less space. It can withstand very high shock loads, and also it can withstand variation in the concentration of organic loads that emanates from any particular chemical industry. One of the main disadvantage or the drawback of this process is the requirement of a very large space. When large space is not available, this process is not a viable one. Next, rotating biological contactors. Rotating biological contactors are one of the oldest technique for treating industrial effluents. In this process, we have a cylindrical tank, and in the cylindrical tank we have a rotating disc mounted on a central shaft. The discs are placed one after another, and when the discs are rotated, a thin film of wastewater is formed over the disc. When a thin film of water is formed over the disc and air is in contact with the disc, the degradation of the wastewater containing organic contaminants occurs. Disc slowly forms a mat-like structure with the help of adhering microorganism over the disc. In the presence of microorganism, the organic materials are degraded into simpler substances. Anaerobic treatment. Anaerobic treatment is the process by which the complex industrial waste water is treated with the help of anaerobic microorganism. When we refer to anaerobic treatment, it is not a single microorganism that degrades this complex wastewater into a simpler substance. It contains a variety of microorganism that degrades this complex material into a simpler material. The overall process is that the complex organic material is converted into methane and carbon dioxide. One of the greatest advantage of anaerobic digestion process is that we get a valuable byproduct called methane, which can be used as an energy source in the industry. The anaerobic process is divided into several steps. First one is the hydrolysis step. The complex organic material is converted into a simpler material with the help of hydrolytic bacteria, and hence the hydrolysis process takes place and it is converted into a range of higher volatile fatty acids. Next group of acid forming bacteria act on the higher fatty acids and they convert that one into simpler fatty acids like acetic acid. Then another group of bacteria converts this acetic acid into methane. That group is called methanogenic bacteria. It is referred as acid utilizing methanogens. During the degradation process, certain amount of hydrogen is formed and carbon dioxide is also formed. This hydrogen combines with carbon dioxide and get converted into methane by a group of hydrogen utilizing bacteria. This process is known as hydrogen utilizing methanogenesis. Among the several anaerobic reactors, upflow anaerobic sludge blanket reactor is widely used in industries. What is meant by upflow anaerobic sludge blanket reactor? An upflow anaerobic sludge blanket reactor is nothing but a reactor where the microorganisms that are present in the wastewater forms a flock like thing and moves from bottommost part of the reactor to the topmost part. When it moves from bottommost part of the reactor to the topmost part of the reactor, the entire anaerobic digestion occurs. One of the most important thing that has to be taken care in an UASB reactor is that the sludge that is formed should be a granular sludge. That means the microorganism forms a flock like thing and it is slowly converted into a granular structure. There are several advantages of this granular structure, that is, when the effluent moves from bottommost part of the reactor to the topmost part of the reactor, these granules adhere to each other and forms a blanket or a bed. As the effluent moves from top to bottom, the degradation process occurs, and as it reaches the topmost part of the reactor, there is a gas solid liquid separator which separates the solids and liquids and gases. Hence, the solids settle to the bottommost part of the reactor. Clear treated effluent moves out of the reactor and gases escapes through the gas collecting chamber. This type of process can accommodate a high shock load and also high strength wastewater. There are several advantages in the anaerobic digestion process. One, it produces very less amount of sludge when compared to aerobic process. Number two, it produces a valuable byproduct called biogas. 3, it requires very less space. Number 4, it can treat a very high strength wastewater. 5, it is a low cost technology. Tertiary treatment, it is employed to remove inorganic solids, bacteria and traces of organics. It is otherwise known as polishing treatment. There are several treatment processes in the tertiary treatment. 1, evaporation. 2, reverse osmosis. 3, dialysis. 4, ion exchange, chemical precipitation and removal by algae. Each has got its own advantages and disadvantages. The selection of these processes depends upon the specific requirement of the wastewater that has to be treated, and hence the wastewater treatment has the pre-treatment, primary treatment, secondary treatment and tertiary treatment.